Welcome to this workshop on graduate applications in engineering. This is what the outline for today's session is going to look like. I'm going to very briefly mention what Project EduAccess does, and then I'm going to introduce you to your wonderful panelists for today, who will then take you through everything that you need to know about making graduate applications in the engineering fields, including applications to master's programs as well as PhD programs, before they also give you some insights into the career prospects in this field. And then, of course, we will move on to a more structured form of the Q&A. But like I said earlier, please feel free to ask any question that comes up during the presentation by either raising your hand or popping your question in the chat. Project EduAccess is a nonprofit organization which aims to improve inclusivity in the higher education as well as professional spaces, especially for individuals coming from marginalized communities in the Global South. And we do this by adopting 4 key interventions: mentoring, counseling, and role modeling, information, advice, and guidance, capacity building and leadership skill development, and evidence-based advocacy. Some of you may already be part of the mentorship programs that we are running this year. So you may be familiar with what goes on the mentoring, counseling, and role modeling side. But for those of you who are just attending our workshops, you know that these workshops are the primary way in which we share information, advice, and guidance on higher education abroad in particular. But sometimes, of course, there's also sessions on more capacity building and leadership skill development side of things. So that's a bit of insight into what we do at Project EduAccess. But let's now talk about today's workshop itself. We are joined by Rachana and Riyya, and this is some insight into what they have been doing so far. Rachana has completed her PhD in chemistry and material science, and she has also, I believe, done a master's in the US. And Riyya, as you can see, has also completed her MS in electrical engineering from UCLA. Between them, they can also speak in Hindi, Marathi, and Riyya, any other languages apart from English that you're able to speak in case we have questions coming in other languages?
I can speak Hindi and I can also speak Tamil, but my Tamil is not as good as my English or Hindi.
Perfect. That's absolutely fine. So you know what other languages the speakers are comfortable speaking in. So if you're unable to articulate a question in English and would prefer to switch to any of the languages that they speak, please feel free to. That's absolutely fine. And on that note, I'm going to stop talking and hand over to Riyya to kick off the main part of this presentation. Over to you, Riyya.
Okay, so I'll be covering the master section of this presentation, and I'll be giving you an overview about the higher education opportunities that are present in different countries. So, of course, by that I mean the master's program, and usually US, Canada, UK, Australia, and I think Europe in general are sought after by a lot of lot of students, at least in India. And there are a lot of universities in these countries that are renowned for their engineering programs, as well as other programs. And they're mainly renowned for the kind of funding they have that they can use for research. Next slide, please. Thanks. Um, So usually the master's programs are designed in a way that is very different from what we have in India, for example. I think in India, a lot of universities, at least at the bachelor's level, are very theoretical. The courses are very theoretical, and oftentimes they just continue the old syllabus that has been going on for years. Whereas the master's programs, at least when it comes to engineering in all these different countries, are designed in a way where you can gain technical expertise, you have a lot of hands on experience, you have research opportunities, and most importantly, you're able to develop skills that can be used in an industry once you start working. At least that's what my experience was in UCLA. So one thing that I would like to share is that UCLA is one of those few universities that offers a lot of flexibility in terms of taking courses as compared to other universities, as long as you're still within your domain or your program. And I decided to take up courses that involved projects because that facilitated my hands-on learning. Of course, a lot of those skills are not being utilized today in my job, but whatever I learned was pretty valuable. So that's how a lot of master's programs are structured. And a lot of them are usually between 1 to 2 years. And they are a combination of core courses, electives, and then you can have a major project or a thesis. So typically, when we are talking about course modules, they cover a lot of advanced topics which are relevant today in terms of the industry that is there. So they keep updating the courses with time, and there can be a lot of topics like computational mechanics, thermodynamics, signal processing, depending on which branch of engineering you choose. And machine learning and AI is becoming very popular these days. So I'm sure you'll find those courses if you're pursuing computer science or electrical engineering, for example. Um, and then they have electives where you choose courses in a lot of these different emerging areas. So um, artificial intelligence and robotics are, I would say that it's a prominent area, but it's also an emerging area. So you'll find electives for these. Um, and then there are other areas too, like renewable energy. So they offer electives like these. And then they also teach you techniques for conducting research. And there's a way of going about that. So they'll teach you everything, the statistical analysis, the kind of simulation tools that are available, as well as lab skills. And then, depending on the program you choose, like if it's an MBA, for example, they are going to teach you fundamentals of management, ethics, as well as leadership skills, so that students can take on managerial roles once they graduate. Next slide. Thanks. So, when you apply for these master's programs, you might come across terms like MSc or M engineering, for example. So, I'll tell you the difference between them. So, when you look at MS or Master of Science, that is present in US and even UK, and usually it refers to master's programs in engineering, for example, or even other sciences where there's a focus on the research part. And it's there in UK and Europe also. The only difference is that instead of seeing an MS, which is common in the US, you might see MSc. But the content, the structure, the focus on research would be the same. And you may also come across programs like MEng, which stands for Masters of Engineering. So in some parts of UK and Canada, and even some universities in US, uh, you have programs called M engineering. So they are more relevant for industry related work. They're very professionally related. So that's the difference between MS or MSc and M engineering. So MS and MSc is just like a nomenclature thing, whereas MS and M engineering come down to the difference in the course structure. Next slide, please. And then this is something that you need to know when you are picking the country where you want to study. So, in terms of just a program structure, in US, you usually have programs for 1 to 2 years. That really depends on the college that you are, the university that you're picking. Um, there may or may not be flexibility because I know that UCLA has a course-based structure in that if you finish the minimum number of courses, depending on whether you take a thesis or non-thesis option, you can finish it in 1.5 years or even 2 years. Whereas other universities are a lot more strict. So that depends on the university you choose. But you can say it's 2 years, and there is some flexibility in coursework and research. Whereas in UK, the duration tends to be shorter. Generally, it's just a year. Um, and UK programs focus on coursework and dissertation. In Australia, again, it can be 1 to 2 years, and it'll be a mix of coursework and research. Um, and then Europe and Canada, again, they are also for 2 years, and they also focus on thesis and research. So in Europe, there is a focus on thesis, and in Canada, there's a focus on research. So when I say research, it doesn't necessarily have to be a thesis. It could be a project as well, but again, depends on the university. Um, so yeah, that's the difference between the two. Next slide, please. Okay, so finally, the this slide is pretty important when it comes to choosing the university. Um, I know that a lot of people like to go for universities that are very popular, and of course, or very highly ranked. And of course, that's something that you should aim for. But my personal suggestion is not to compromise on the branch of uh, engineering or the branch of program that you're going for, because a lot of times if students have to pick between their favorite branch of engineering, but at a lower ranked university, and a higher ranked university offering them a program that is not really of their liking, they tend to go for the second one because of the university ranking. I don't think that's the best approach, but that is my suggestion. So this is one thing you can choose to keep in mind while you're picking a university. um, and then there are all these factors that you can use to evaluate and make a choice. So definitely google the reputation of these universities as well as the rankings. So QS and THE are some very prominent websites that actually tell you about the university rankings, and they also tell you how each program is ranked. So some universities can be good in general, but the program that you are looking at may not be something may not be a program for which the university is highly ranked. So you want to keep that in mind. And then of course specialization is very important. So make sure you choose a program that aligns with your career goals and your interests. um, Try to research about the kind of funding opportunities which are available for these universities, whether they research and in cut with research in the upcoming fields and are using cutting edge technologies or not. So that will be very beneficial for you. um, a lot of universities also have tie-ups with the industry, and you have these thing called career fairs that happen throughout the duration of your program. So what happens is there are employees of companies who come over to these career fairs, and they spend about 5 minutes talking to you where you can talk about your achievements, and they may offer to set up interview calls. So some universities have very good connections, so make sure you research this part while picking a university. The one thing that's not talked about very often, but should be an important consideration, is location. So whenever you're picking a university, you need to keep the location in mind, because I'm assuming that a lot of you would want to work in that country after graduating, and so you want to research about the the locations where where job opportunities are present in your field. So for example, if you're talking about engineering, specifically software or electrical engineering, uh, Northern California is very popular because there are a lot of jobs that are available. It's called the Bay Area or the Silicon Valley. So when I was looking for universities, I picked a lot of universities within California, because when you're interviewing, they're going to ask you whether you can relocate or not. and that becomes a deciding factor in offering a job to you. So definitely research about the location. I can't confirm, but I know that Michigan is a good place for mechanical engineering opportunities. Texas is very good for mechanical and robotics. So this should be a part of your research before you pick a university. And then look into financial support. Look at the scholarship opportunities that are available. uh, s- from my experience, not all US universities offer scholarship opportunities, but they have jobs like teaching assistant or research assistant. And that's how a lot of students are actually able to get scholarship, because they are paid for it. They are paid stipend, and they are able to part at least a cover of at least a part of their fee, or at least that stipend is enough to cover their living expenses. So keep a lookout on these opportunities. Um, and then, of course, look at the kind of student support services that are available, whether there are mentoring opportunities, whether there are um, is there counseling support that is available, career counseling as well as counseling in general. So uh, look into these factors while you're picking a university. Next slide. Thank- Thanks. Okay, so I think Rachana can take over from here.
Thank you so much, Riyya. Actually, that was a very detailed explanation, and a lot of the points that Riyya mentioned so well apply also to a PhD. So I will kind of take a shortcut and mention or talk about things which you should consider, especially when you're if you're looking for doing a PhD. So, what is a PhD, right? Or specifically PhD in engineering. Any kind of PhD, the point is it is essentially the highest academic degree you can get in that field, and it's about creating an original research idea and making an original contribution to that field. So specifically in engineering, that would mean that you work on a project, typically closely with a faculty member. So you will have a research supervisor or a host supervisor, principal investigator. There are many different names for this job. So you will have a direct supervisor who will be your thesis supervisor, who will supervise you on day-to-day things, talk to you about your project, give you ideas or guidance on how to go about it. But the essential idea is that a PhD means that you do an independent project mostly by yourself and make an original contribution. So regarding timeline, typically, so depending on where you are and how the programs are structured, it can take between 3 to 6 years. So, or even more. So it depends on, so for example, to give you very concrete examples, the PhD programs in the UK are designed to be 3 to 4 years. Which means that after that timeline, after 3 or 4 years, your funding is essentially over, and so in engineering or any kind of STEM field, your lab time is over. So after that, if you need any more time to write your thesis or complete any kind of other work, that means either you are self-funding or you're dependent on external funding outside of that program. Whereas in the US or in the UK, in the US or in certain countries in Europe, it essentially depends on how much funding your supervisor has, what kind of grants they're on, are they willing to support you beyond a certain point, and if they think that whatever project you've been working on, has it culminated into a research output that is enough to let you graduate. So it depends. So the timeline depends on these things. Typically in engineering or in STEM, the way I've seen things happen is that you are part of a research group. So there will be a principal investigator who is either a professor or a faculty member, and each faculty member has a research group. So it'll be a bunch of postdocs, research assistants, PhD students, sometimes masters or bachelor students, maybe a technician, and you're part of this research group. And the idea is that everybody's projects are aligned with each other, and more importantly aligned with the research interests of the professor, but you still have your own project, right? So in this context, what I've seen is it's very, very important that you define your own research goals. So at the very beginning, in the first, I mean, ideally before you start, but ideally in the first 4 to 6 months, you should be clear, okay, this is my project. How am I setting it apart from my group members? How is this making an individual contribution, along with working with other people in the group, right? So this can be a little bit tricky to navigate, but it's very important that you do it from the get-go. And the most important part is that what defines a PhD, or what is the expected outcome at the end. So the main outcome is that you have a detailed dissertation or thesis on your topic. You submit it. In all cases, almost, you have a oral examination, which is called a defense, where you present your results. You face a committee of thesis committee. Again, depends according to country how many people are there, but they will really question you on your ideas, on your research. They will really try to get to the bottom of how do you defend this original contribution that you've made. And in some cases, at least I remember in some parts of the US, you also need peer-reviewed publications to graduate. So along with your thesis, your supervisor will demand that you have peer-reviewed publications published or at least submitted in academic journals. Yeah. So how is it structured? So as most, I mean, the preface to everything is it depends on where you're doing your PhD. And different programs in different countries are structured differently. So especially in the US, I know that coursework plays a huge role. So for the first 1 or 2 years, you're expected to take courses either on fundamental topics which are key to your area, but also some additional ones, just like Riyya mentioned. So electives, or even some courses on research tools, or such as like statistical analysis, or which are going to help you achieve your research goals, or something like that. If you look at programs in the UK or in Europe, they are more focused on the research. So you're expected to start working in the lab, maybe right from the first day. The whole idea is that, okay, the main focus of the program is the research project. So that's mostly what you do. In some cases, you may also collaborate with either industry or government organizations. So I know that, for example, in Germany, there are PhD programs where you can either part of the program or the entirety of the program is affiliated to a company. So from experience, I know that in engineering, mechanical engineering, you can do a PhD with a company such as Bosch or Daimler or Mercedes. You essentially work in the company, you're employed on their payroll, but at the end of those 3 or 4 years, you're expected to publish your results as a thesis, or it's supposed to culminate as a PhD dissertation at the end of it. So there are different program structures, and what I would advise you is that you think about which of these structures is more suitable to you based on, one, your current position and your future goals. So for example, when I started my PhD, I really thought that I did not have enough fundamentals or coursework, fundamental ideas about the topic that I was getting into. So even though it was not really mandatory, I took a lot of coursework just to sharpen those concepts. I also took some courses on research tools, or there are also courses offered on other soft skills, like how do you write a research paper. So things which are very, very essential during a PhD. Many universities and institutions offer coursework on it, and it's really up to you to think about, okay, where am I lacking? What do I need to sharpen? What is an additional input that I need? And as I mentioned, the future. So if you, of course, plans can change, and nobody's asked. I mean, it's nobody's saying that you should know right from the beginning what your next steps are. But if you're inclined more towards the industry, or more towards academia, or more towards other areas of a post-PhD career, whether it's in public policy or research communication, whatever that is, you can then tailor your PhD program accordingly. So then you can find opportunities that will give you the skills to develop your profile towards these future opportunities. Yeah. So nomenclature. So just as Riyya mentioned, I think for PhDs, it's less less diverse. So most common one is PhD. I implore all of you to look up what that means, what that stands for in Latin, and remember that. But that's usually what is awarded to you. Depending on other countries, so in the UK, you have DSc, or for University of Oxford, you have DPhil, which stands for Doctor of Philosophy. In Germany, especially, you get Dr. Ing. I had, for example, Dr. Reinhardt, which was Doctor of Natural Sciences. So it's country specific, but essentially all of these mean that you have achieved this highest academic degree in your field. So it does not mean that, I mean, they all mean the same thing. So you do your PhD and you get a title, and depending on where you are, these can vary. Right. So picking the country. So just like Riyya also mentioned, and what we have been talking about so far, each program is structured differently in terms of timeline, in terms of what the program entails, what the focus is. So you really should ask yourself, what are your current requirements and your future goals? And that will help you to pick a better program, or pick the program which is more suitable to your needs. So just to give you an example, for example, the PhD courses in the UK are very, very strict with regards to the timeline. It's 3 or 4 years, and after that, you essentially have to graduate. So just as an example, if you're a person who's more inclined towards industry opportunities, that's actually a better program for you, because you have a fixed timeline. You know, these are the skills you're going to develop. These are the projects that you're going to do. And other things which can be very time sensitive, or kind of out of your control, like publications and projects and other research outputs, you're not really they won't really affect your progress, right? Whereas if you are someone who intends to stay in academia, stay in research, what you want is, you want a little bit of more time to get these research outputs. So to get maybe published papers, or to present your work at conferences, have a bit more time to network within the academic community. And in this setting, a bit more relaxed, flexible timeline is in your favor, right? So then I would suggest you look at programs in the USA or Europe, because that's more tailored to what your requirements are. On the other hand, if you think, okay, I really need some coursework, I have no idea what research skills are, I really need a refreshment course in my fundamentals, you should be looking at a program which gives you that opportunity to get those coursework. So something like that. So really look into what the program is, how is it structured, and before you do that, think about what your needs are, past, present, and future. And that will put you in a better position to pick not just the country, but also the specific program in that country and in that in your area of engineering. Right, picking the program. So I want to preface this by saying that a PhD really is a very significant time and life commitment. It's not just 3 or 4 years of your life, but it's 3 or 4 in the formative years of your life. It's going to make a very big change in your life, right? So it's a time when maybe, I mean, just the way PhD programs are designed, either they're not really, I mean, you won't be competing with your peers in terms of industry salaries. So that's a factor. You are going to be somewhere in this middle zone of being a student, but also having like a full-time job, navigating a lot of new things. So before picking the specific program, I would really implore everyone to think about, why am I doing a PhD? What are my reasons for it? And is it really the best thing for me in terms of my career goals, my personal goals, things like that. So it do not underestimate the life-changing effect these 4 or 5 years are going to have on you. That said, uh, because all of this, is a big factor, when you are choosing a PhD course, of course, the most important things are the area, the project, where are you doing it? So in terms of which university, what kind of facilities they have, what kind of resources they have, What is the location? So most of these things which Riyya already mentioned, but specifically for a PhD, I would say that what is more important is that you look at what kind of advisor are you going to be working with? What is their mentorship style? How big of the research group it is? So especially for a PhD, I would really, really encourage you to get in touch with people who are currently working there, or past alumni, get an idea of how good the supervisor is, how good the institute is, how good the university is in terms of providing other support that you need. So, for example, most universities will have a tech team, a lab safety team, especially in engineering, right? So, even if you are, so the difference is, okay, if you have a wet lab PhD, which means it's an experimental one, you're working in the lab, that has certain considerations. If you have a dry lab PhD where you're more focused on a simulation or a computational project, that will have different requirements. Find out if the program you're applying to are willing to support you. Do they have the resources to support you in these areas? And I will completely second what Riyya said in terms of this balance between the reputation of the university or the reputation of even the supervisor and your research needs. So what I've seen happen is that, sometimes at these really reputed universities, or maybe the supervisor that you're applying to, let's say they have a Nobel Prize, right? Who doesn't want to work with them? What ends up happening is you might be in a situation where this person has a very big research group, and they're not actually in a position to give you the time or the resources to mentor you. So it really depends on what your career goals are. If you are going into a PhD with the intention that, no, I really want to develop my research skills, I want to develop my experimental skills, or I really want to become an expert in this subtopic of my engineering field, you want a mentor who's willing to give you that time. So do put in the work to find out if wherever you're applying is going to provide that for you, because that is going to determine how happy you are during the PhD and how good of an outcome you're going to get from it. So yeah, I know I mixed up all of these, but this was my general advice, that do look at all of these factors before choosing a PhD position. How good is the mentor? What are the working conditions? What is their working style? What is the general work environment in that research group, in that department? Are they offering facilities and resources that you need for your research? Do they have other, let's say, opportunities for networking, for career building, for skill development, all of these things, right? Do they have opportunities for teaching, for supervising, all of these things? So think about what you want to get out of your PhD, and is that potential program willing to offer you those? Yeah. Right. So career prospects, I thought I'll talk a little bit about the academic side, because that's my current career path. So once you complete your PhD, you can have different career paths. Typically, the binary is that, or you can either take up a job in academia, so you follow up with a postdoc or a research fellowship, and then continue on this path to become a professor or a faculty member, or the other opportunities that you go into the industry, have an industrial job. I do want to take this moment to talk about other job opportunities or career prospects you may have. So you can see on the slide, starting your own entrepreneurial venture is definitely one career option. The other ones, which are not that common or not that widely advertised, is that you can think about going into public policy. You can think about going into science communication. So all of these academic journals that you see, the people who work there in a review capacity have PhDs and have professional technical education. So that is also a very, very important career path that you can take. So really don't limit yourself to just this academia versus industry binary, and think about or explore other options as well. If you do decide to go down the academic path, yes, the idea is that the next step would be that you look at for a potential postdoc position in engineering or any STEM field that is not just encouraged but highly required as well. Because if a PhD is about doing independent research, a postdoc is a little bit more than that. So you do your independent research, but also kind of support other people, other PhD students and master students along with it. For that, what you would require is you would require very good publications. You would also require to have some teaching experience, some supervision experience. Other things that you should then focus on during your PhD would be looking at opportunities for outreach events or mentorship events. So things like that. So it really depends on if you want to go down an academic path that will tell you what do you need to do or what skills do you need to develop during your PhD. And I'm happy to have a chat with anyone who wants to talk more about it. But I think at this point, I'll hand over to Riyya to talk about the career prospects in an industry capacity. Thank you.
Yeah, I think
Sorry,
this
I didn't realize I was on mute. Thank you, Rachna. That was actually very insightful, and I totally agree with your point about how you and your aspirations can kind of be lost when you're in a big university with a very uh, reputed professor. So I've not done a PhD, but I know for a fact that that is something that may happen. Um, Before I go into the career prospects, there's just one thing I remembered that I just want to share. One of the other considerations that you can keep in mind while picking a university is that um, I think Rachna can speak better for I think Germany. That's where you studied, but in the US there are three types of universities: private, public, and state universities. So private universities are the most expensive, followed by public, and then the state universities. So that is again something you can keep in mind. The only difference is, I mean, the difference is that when you look at private universities, the student to teacher ratio is not that high as compared to private and state universities. That being said, don't be discouraged by this ratio. I went to a public university, and I took a class where there were about 200 students. I still had the opportunity to talk to the professor in a one-to-one capacity when I was having issues with the course, and he was very helpful throughout. So yeah, just don't be discouraged by that thing. Merely speaking from a financial money point of view. So that being said, we can talk about the career prospects. Um, I think what you said, Rashna, that was very interesting. We shouldn't really focus on the academia versus industry divide. So I think that's quite interesting. So definitely research about the different opportunities that are available within your field. Career fairs are one of the good ways to go about this. Universities have their own portals. They may or may not have. I know that UCLA had a portal where there were regular job postings, and I've had luck with that. So definitely do that. Um, Please get in touch with your alumni. Like once you join the university, get in touch with your seniors and your alumni through LinkedIn, because in the US at least, you land jobs through networking, and usually people who've been to the same university as you are a lot more likely to help you out. They are a lot more likely to put in a referral for you, which is very important. You don't get a job because of a referral, but you're able to get interviews. At least your resume would be seen by the company or the team. So please do that. And I think the one thing that is mentioned here is entrepreneurial ventures. That is also a very good option, but please keep in mind that entrepreneurial ventures are not exactly very straightforward as compared to doing a job. Um, I say this because, besides, of course, having an idea in mind and everything, There are a lot of work permit restrictions depending on the country you choose, and a lot of them usually require some kind of minimum funding amount that you should be having. Uh, so definitely keep this in mind. I'm not trying to discourage any of you, but I just want you all to keep these things in mind. So definitely, any kind of employment opportunity, you want to look into the work permit regulations of the country that you're choosing. So I think that's all I can say for the career prospects when it comes to the industry. Oh, and they when companies are interviewing you, they are going to ask you about any previous job experience in your home country, any internship opportunities that you pursued while pursuing the master's program, as well as the skills in projects. Which is why, again, I'm saying that when you do your research, when you pick a university, look for universities that focus on hands-on training, because a lot of companies are looking for skills. And in my experience, skills are a lot more important as compared to um, the level of degree that you have. So definitely keep that in mind. Yeah. So yeah, at this point, both Rachana and I are open to any questions that you guys may have.
Perfect. Thank you so much, Riyya and Rachana. That was succinct, super insightful, beautifully done. Thank you. I'm just going to turn to the audience now. Just to reiterate, you're more than welcome to raise your hand and ask any and all questions that you have. Please don't think that your question is silly or whatever. We are here precisely to help you, even with the so-called silly questions. So please don't hesitate to
Yeah, no
ask
such thing.
anything that pops in your mind. Yeah. But if you prefer putting your questions in chat, that's also absolutely fine. Maybe we'll give them a couple of seconds to warm into the idea of asking questions. Okay, I've got one question here by DM. Are there any differences between jurisdictions when it comes to taking tests like GRE? Is this a requirement for graduate applications in engineering?
Yes, in a lot of sorry, a lot of universities do require GRE, and while there's no minimum score, uh, while there's no cutoff specified, they are looking at a sorry, they are looking at a minimum score. I know that some universities have even waived off this requirement, but again, it could be a pandemic related thing, or it could have just been a one-off thing. And universities, they keep changing their requirements. So definitely take the GRE exam. And if you want to get good universities, again, I am speaking from 2018. That's my point of view, because that's when I took the exam. I don't know, things may have changed, but back then, out of 340, a minimum score of 320 was needed for the good universities. And I think 300 was easily a minimum. So keep that in mind. But again, I'm not sure about what exactly they meant by jurisdiction requirements. But I hope I answered your question. Rachna, is there anything you want to add to that?
No, because I'm even more outdated than you. But I've read it in the news that so at the time when I was doing my master's applications to the US, it was definitely a requirement for all. So the general GRE, and then some universities required the subject GRE as well. And in the recent years, I've been reading that some universities have kind of waived off the GRE, or it's no longer a requirement. But yeah, detailed research when you apply would be required.
And Rachana, is this a requirement for PhDs as well? I think when they said jurisdictions, they meant like country-wise differences. Any like this
So the
GRE?
GRE is only for the US. And yeah, so if you're directly applying for a PhD program, I think it's definitely a requirement.
Perfect. There is what I believe a direct question for both of you on whether they can connect with you on LinkedIn for any further questions or guidance.
Okay, so I'm not a industry person, so I don't think I've opened my LinkedIn page in a very long time. Riyya can scold me for it, but I'm always available on email. So I'll post my email in the chat, and anyone can feel free to contact me there.
I actually get a lot of emails, most of which are spam. So, uh, yeah, I think LinkedIn is a very good place for you all to connect with me. I do want to be upfront that I'm having a pretty busy schedule because of work and all these things. But again, I will try my best to help you guys out. And I may not be active on LinkedIn every single day, but I'll try my best to get back to you and your questions. So, of course, feel free to connect with me on LinkedIn. Just yeah, just search my name. You'll see it, and it has the same photo as the one shown in the presentation.
And we can subvert some of our work on Gayathree and say that it's always a good idea to email operations at Project EduAccess, and they can put you in touch with the right person.
Always happy to do that, needless to say. But that's really kind of both of you. Thank you, guys. There's just one more question that's been sent to me via DM, asking essentially about comparing a master's or a PhD in engineering in India versus doing it abroad. Any insights into just the choice of studying abroad?
I mean, I think very honestly, I'll talk about the PhD, but very honestly, I think it's I mean, all the reasons for comparison for me at least were I mean, completely different from the technical aspect of it. I have many colleagues who have done their PhD in India, and if I look at the technical skills we were exposed to or the facilities, I mean, if you compare like a top university like IIT or ISC in India and any other university in UK or Europe, I wouldn't say there was any difference with our technical skills. In fact, a lot of my counterparts who did their PhDs in India had a much better experience in terms of guidance, mentorship, um, availability to resources, things like that. The differences are more on a personal level that, okay, if you're doing your education abroad, you are exposed to a different kind of lifestyle, more diversity in terms of people, ideas, culture, etc. There can be one very significant difference, especially in terms of while doing the PhD, is for travel resources. So when you're doing a PhD in engineering or any STEM field in a wet lab experience, in a wet lab setting, I think you do get access to a lot of resources like experimental equipment and everything, but the resources available for travel are very limited. So you might not get opportunities to travel to conferences as much as somebody in Europe or UK or I mean abroad will have. The simple reason for that is that the expenses are also uh, not proportionate. So if you have to travel from India for a conference to the US or somewhere in Europe, it's going to cost a lot more. Also because of the currency difference. Than somebody who's already in Europe who just has to like take a train to go to a conference. So that is the major difference that I have seen. The other again, so it's mostly financial resources based. The difference. So things like if you want to publish in a journal, most journals have open access fees which are quite high, and some Indian universities or programs are not able to provide for those. So things like that. But in terms of the skills, the technical knowledge, the overall technical aspect of your PhD, I think there is no difference, very honestly.
Um, I I don't know of I don't know a lot of people who have pursued a master's in India. So I don't think I can give a very good picture of the difference between Indian programs and programs in US, for example. Um, but I'm pretty sure it's similar to what Rachna was saying, that if you go to a very good university in India, uh, like IITs or IISc, then you would be exposed to a lot of different skill set. For example, if you're talking about masters, and at least that's what I have seen in my job experience. I mean, that's what I have gained through my job experience. That there are people who came straight from India who did not really pursue a master's. Again, we'll not go into that thing, but um, I know that their skill sets are not that different from the people who studied in the US. But of course, I think if you go to a very good university in the US, for example, there could be a lot of funding opportunities, and that you may not get if you study in India. So I think that's the only difference. Because I think the financial resource is very important when you're conducting a research. My focus was more on the skills. So again, I can't give the best picture of the difference between the two, but yeah, I'm not sure if that answers your question, but uh, again, yeah, that's what my experience has been.
No, that's super helpful, both of you. And I mean, at the end of the day, it is a personal choice, and each
Yeah.
person, I'm sure, has a different set of factors that influence that decision. So that's great. I don't see any other questions in the chat, but I'm just going to turn to our attendees and check if anybody would like to ask any final questions. In the meantime, for those of you who are wondering, the recording of this session will be available on Project EduAccess's YouTube channel in a few days from today. I'm just going to drop the link to our YouTube channel here in the chat so you have that with you. In case you have any final questions, please feel free to drop them in the chat or raise your hand and ask. But if not, and if you want to think over everything that you have heard today and email questions later, that's also absolutely fine. Of course, as Rachana and Riyya said, they're also available to take questions from you via email or on LinkedIn. But if it's easier, you're also welcome to drop an email to us at info@projecteduaccess.com if you're not a mentee with us currently. But if you are a mentee with us, then you know that you can email the operations team or the programs team, and we'll try our best to get your questions answered. I don't see any raised hands. I don't see any questions. So I think now is a good time for us to wrap this up. Once again, a huge thanks, Riyya and Rachana, for doing this with us.
A pleasure.
And
Thank you, Gayathree, for moderating.
thank you.
Thank you so much, Gayatri, for organizing the whole thing, and
Yeah,
being very
absolutely.
accommodative of my schedule. And thanks to you too, Rachna, for
It
agreeing
was,
to the time change.
it was easier. It was later in the day. So I was like, sure.
Okay. Yeah.
No, this was
That's
really
good.
good. I really enjoyed this session.
Yeah, same. I hope it was insightful for all of you and the others who were there in the presentation earlier.
No, I'm sure it was. Thank you so much, both, and
Thank
see you
you.
at another one of these
Okay.
sessions in the future.
See you.
Okay,
Bye. Good
thank
luck.
you.
Bye
Have a
bye.
good day, all. Bye.
You too. Bye.